Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 25 to 29 of the January 2017 Algebra 1 Common Core New York Regents exam. Alright, let's take a look at question number 25. It reads, in attempting to solve the system of equations y equals 3x minus 2 and 6x minus 2y equals 4, John graphed the two equations on his graphing calculator. Because he saw only one line, John wrote that the answer to the system is the empty set. Is he correct? Explain your answer. Okay, before we do that, there is something that I would like you to remember. When you're solving systems of linear equations, you can either have no solution, one solution, or infinitely many solution. Okay, so recall when solving systems, and the two equations in reduced form are identical, then you have infinitely many solutions. Okay, so that's one of the cases, one of the outcomes of solving systems of linear equations. So let's take a look at what we have here. We have y equals 3x minus 2 and 6x minus 2y equals 4. Okay, this is your slope-intercept form right here, and this form right here is your standard form. So what we're going to do is put both of them in the same form, reduce it completely, and see what happens. Okay, if we have identical equations, then we'll have infinitely many solutions. But if only their slopes are identical and their y-intercepts are different, then we'll have no solution, which is equivalent to saying the solution is the empty set. Okay? Alright, so this is already in simplified form. Let's place this in slope-intercept form. Okay, so let's call this equation 1 and call this equation 2. Okay, so to do this, to get it in a slope-intercept form is the same thing as saying to solve this equation for y. So we'll move 6x to the left and divide by negative 2y. Okay, so subtract 6x from both sides, and I have negative 2y equals negative 6x plus 4. And then you divide the entire equation by negative 2. And what results? You get y equals negative 6 over negative 2 slash and dash. You have positive 3x minus plus over minus is minus. Okay, remember the rule. Anytime you divide numbers with different signs, the result is always negative. Okay, and anytime you divide number with the same signs, the result is always positive. Now what do you notice about these two lines? They are identical. So if you draw a line on top of another, how many times do they intersect? They intersect infinite number of times. Okay, so let's go back to the question. Well, let's write down the answer first. We have infinitely many solutions. Infinitely many solutions since the lines are identical. Okay, now let's go back to John's remark. John saw only one line. John wrote that the answer to the system is the empty set. Is he correct? So we want to make sure we answer the question and also explain our reasoning. Okay, so the answer is no. John is not correct. Is not correct. Why is that? Because there are infinitely many solutions. Okay? So if you graph, let me just show you what's going on here. Let's say you graph the two lines, right? So let's go ahead and graph them real quick. The y-intercept is -2. So for the first one, you rise 3, 1, 2, 3, and run 1. Okay? So rise 3, run 1, that's the slope. And your y-intercept is -2. So this is the first line right here. Something like this. And the second line will be graphed on top of the first line. Okay? So let's go ahead and graph it. I'm going to make it green. So I graph it on top like that. So where do they intersect? Where are the points of intersection? Everywhere. Okay, so they intersect everywhere on the domain. So that means you have infinitely many solutions. Now, what kind of scenario will make John's answer true? Let's say the second line were not this. Let's say the second line where y equals 3x plus 2. Now what would that look like? That will cause the y-intercept to rise up to positive 2, 1, 2. And in this case, there are no intersections, which means that the answer will be the empty set. Okay? So if you have the same identical slopes on different y-intercepts, you have no intersections, no solutions, so your answer will be the empty set. But that is not what we have here. In this situation, we have identical equations, which means that the line overlap perfectly, and which results in infinitely many solutions. Okay? All right, let's take a look at question 26. It reads, a typical marathon is 26.2 miles. Alan averages 12 kilometers per hour when running in marathons. Determine how long it would take Alan to complete a marathon to the nearest tenth of an hour, and then justify your answer. Okay, so we're looking for what are we looking for here? We're looking for time, okay? And we're given some pieces of information. We're given a distance, and we are given a rate. And then when they say how long, what is that? That's time. Now, what formula relates distance, rate, and time? It is the dirt formula. Okay, so recall the dirt formula. Dirt, okay? This basically tells you that distance is equal to rate multiplied by time. And there are two other variations of this. If I divide by rate, this formula tells me that rate is distance divided by time. And this formula also tells me that time is distance divided by rate. Okay, so these are the three variations of the dirt formula. Okay, so since we have the formula identified, let's go ahead and solve it. We're looking for time, so we're going to be using this formula right here. Time is equal to distance divided by rate. Okay, so what is our distance? Our distance is 26.2 miles, and our rate is 12 kilometers per hour. Are we ready to substitute these into our formula to calculate for time, which we do not know? The answer is no. We have a big problem here, and that's the unit of measuring distance. The rate is in kilometers and the distance is in miles, so we cannot just simply multiply these two together because the units are inconsistent. So what must we do? We have to either work in miles or kilometers. Okay? So side note, units must be consistent. okay, across all the measures. So if you're talking about time, if you're talking about time measurement, you want to use the same like hours. Everything else you do with hours. If you're working with distance, either you stick with miles or kilometers. You cannot have different units, different standards of measure within the same formula. It doesn't work. Okay, so how about we convert 26.2 miles to kilometers? Okay, so let's go ahead and do that. Convert 26.2 miles to kilometers. So what we're going to do here is multiply 26.2 miles by the appropriate conversion factor. Okay, now if you take a look at your reference sheet, you will see that 1 kilometer is 0.62 miles. Okay, so how do we write it? We just multiply this by 1 kilometer over 0.62 miles. Now, why did I set it up like this? We are going from miles to kilometers, so I want to set up my conversion factor in such a way that miles cancel out and the only unit left standing is kilometers. Okay, so these miles cancel out. So our resulting answer will be 26 times 1, which is 26.2 times 1, which is 26.2 divided by 0.62. So let's go ahead and do that. So 26.2 divided by 0.62, we have 42.2581. What on earth is that? What unit is that? That is 26.2 miles in kilometer form. Okay, so let's go ahead and write it down. Our distance in kilometers is 42.2581. Okay, I'm not rounding yet because I have to wait until the final answer before I round so I don't lose accuracy. So we have distance, which is 42.2581 km, kilometers, which is good. Our rate is 12 kilometers per hour, which is good. We have consistency across the distance measures here. Okay, now we're ready to find time. Using our dirt formula, time is distance, 42.2581 divided by rate, 12. Okay, and I'll find it's going to be in hours. So let's go ahead and carry out the computation. So we're going to have, what are we going to have? Let's use a calculator. That answer I have divided by 12. And we have 3.52 hours. Okay, so our time is 3.52. But let's go back to the question. 521515. We're asked to round to the nearest tenth or just one decimal place. So we're rounding to that place right there. The number behind is 5 or less, is less than 5, sorry, so that means we're going to truncate. Okay, no need to round up. So our time to the nearest tenth is going to be 3.5 hours. Okay, so one thing you want to keep in mind when working with distance rate problems, distance rate time problems, is watch out for inconsistency with the units. And if you find out that the units don't align, you want to carry out the necessary conversions so you can solve the problem correctly. Alright, let's take a look at problem number 27. We're asked to solve the linear inequality provided. So if you look at this inequality that we have here, it looks problematic, and that is because of the presence of decimals. Okay, so one tip that you want to keep in mind when solving equations or inequalities is that it's always optimal to eliminate decimal points wherever possible. Okay, so tip: when solving equations and inequalities, algebraically, that's by hand, it is um, very beneficial to eliminate the decimals. Okay, it's beneficial to eliminate um, the decimals. Okay. All right. So let's see if we can apply this tip to this problem. Can I get rid of these decimal points so that I can just deal with numbers? That's the question. So take a look at the decimals. There is only one decimal place in all the decimals here. So that means we have 1 0. So what are we going to multiply by? We're going to multiply both sides of the equation by 10. That will cause the decimal point on each value, each numerical value, including the coefficients, to shift to the right by one place. So this will go to the right one place, this to the right one place, this to the right one place, and this one is going to go to the right one place. So what will it look like? We're going to have 18 minus 4y is greater than or equal to 22y minus 20y. Okay? So this looks much better. Alright, so let's go ahead and solve. We want to get y by itself. So let us see what we can do here. A real quick correction. We don't have a y. There's no y over here. Put a y there. So it's just 22.2. So let me just scratch it out. So there's no y there. Scratch that out. Okay, so what we're going to do now, we're going to go ahead and move all the terms, all the constants to one side, and then the variables to one side. Okay, so let's add 4y to both sides. And then we're going to subtract 22 from both sides. Okay, subtract 22, subtract 22. And then we will have, what is 18 minus 22? Well, we're going to subtract and keep the sign of the bigger one, which is 4, okay? So we have negative 4 is greater than or equal to, that adds up to 0, just like this right here. Negative 20 plus 4 is negative 16. Okay, remember when you're adding or subtracting numbers with different signs, you subtract and keep the sign of the bigger one. Now, how do we get y by itself? Divide both sides by negative 16. Okay, so what is negative 4 divided by 16? First of all, we have minus and a minus, which is going to make it positive. We can slash and dash. Now, one common mistake students make is they say that, oh wait, 4 over 16 is 4. That is incorrect. We have 4 over 16. If you divide the numerator by 4 and the denominator by 4, what do you end up with? 1 over 4, not 4. So be careful with that. Okay? So if we reduce this fraction, divide top and bottom by 4, I'm going to end up with 1 over 4. Now, inequality, this is a caution you want to keep in mind. Whenever you multiply an inequality by a negative number, what happens? You have to switch the inequality symbol. Okay, switch the inequality. Switch the inequality. That's another point you do not want to forget. Okay, so what does that mean in the context of this problem? It means that this inequality is no longer greater than or equal to, now it becomes less than or equal to. 16 over 16 as y. So 1/4 is less than or equal to y, or you can say y is greater than or equal to 1/4. Okay, so two main things you want to keep in mind here. Number one is that 4 over 16 is not 4, it's 1/4. And secondly, if you divide by a negative, do not forget to switch the orientation of your inequality symbol. Alrighty? Alright, let's take a look at question 28. It says, Jacob is working on his math homework. He decides that the sum of the expression 1/3 plus 6 root 5 over 7 must be rational because it is a fraction. Is Jacob correct? Explain your reasoning. So to do this, we're going to take a look at one of our formulas from our EPIC Algebra 1 Common Core Regents formula sheet. If you want to gain access to our formula sheet, just go to math.serve.com under New York Regents, and you're going to see our formula sheet that has all the formulas you need to know to do well on the Algebra 1 Regents exam. Okay, this is just one of the formulas. Now it tells us what happens when you add, subtract, multiply. When you add and multiply rationals and irrationals. So let's go ahead and quantify what set these two numbers belong to. The add-ins. 1/3. This number, this fraction, can be expressed as a quotient, the quotient of two integers. So if you can express a number as the quotient of two integers, it's a rational number. Okay? Now, how about this number right here? Because of this rad 5, which is a radical that has been simplified completely, if you have a number that the radical component has been simplified completely and the radical remains, because of the presence of that radical, the entire number becomes irrational. Okay, irrationals has that radical component to it. Irrationals cannot be expressed as a quotient of two integers. So what we have here, the nature of the solution is what? The solution is basically a rational number plus an irrational number. What do you get when you combine a rational and irrational number together? The answer is this scenario right here. Rational plus irrational is always irrational. Okay? So let's go ahead and work it out. If we wanted to combine the two numbers, the two fractions, we have 1/3 plus 6 root 5 over 7. To combine these two, we need to find the LCD, which is 21. So this we'll multiply this by 3, top and bottom, and multiply this number here by 7. Okay, so it's going to become 7 over 21 plus 18 rad 5 over 21. The denominators are now identical, so we can combine the numbers to give us 7. 7 plus 18 root 5 over 21. Okay, so what does this show us? It shows us that if you have this one's rational plus an irrational number, which is this one, it gives us a final answer that, you see this radical piece right here, automatically makes this irrational. Alrighty, so let's answer the question. The question is Jacob correct? Explain your reasoning. So what are we going to say? Jacob said that the solution is rational, but it's not. So Jacob is not correct. Why? Because the sum of a rational and irrational number is always what? Irrational. Always. Okay? And that's not consistent with what Jacob said. Alright, let's take a look at question number 29. It says, graph the inequality y is greater than 2x minus 5 on the set of axes below and state the coordinates of a point in its solution. The coordinates of a point in its solution. Okay, so let's go ahead and graph it. Alright, so we have the linear inequality y is greater than 2x minus 5. Okay, first things first, you recall y equals mx plus b. This tells us that m is the slope, right? And b is your y-intercept. Well, this linear inequality is in the same format, so it automatically tells us that the slope m is 2 over 1, which means that we're going to be rising 2 and running 1. So rise over run. Our y-intercept b is negative 5. This is where we're going to begin on our y-axis. Now, what does this inequality tell us? I view it like special effects. This inequality lesson tells us that the line is going to be broken and we're going to shade. Greater means where? It's shaded top, shade above. So we're going to have a broken line and we're going to be shading above the line. That line will have a y-intercept of negative 5 and a slope of 2. Let's go ahead and graph it. So 1, 2, 3, 4, 5. There goes our y-intercept. Going to rise 1, 2, and run 1. Let's do another one. 1, 2, run 1. Okay, so what would our line look like? It's going to be a broken line because we do not have a dash underneath the inequality symbol, which indicates that the boundary values are part of the solution set. So we need to exclude them with the broken effect on the line. Where we're going to shade. Imagine that this is a roof, right? Where's the top and where's the bottom? This is the top, right? So we're going to shade above. So we just put lines here. So let's just shade this entire region right here. Or I can just use my line tool. So this entire region right here. This entire region is our solution region. What does it mean to have a solution region? We have a solution region where any coordinate pair that falls in this region qualifies as a solution. Okay? So we have to state the coordinates of a point in its solution, just any point. So how about I pick this point right here, 0, 0. 0, 0 is a solution. Why? Because it falls in the shaded region. Okay, so 0, 0 is a solution since it falls in the shaded region. Now, let's just check, okay? Just check to see if this is a solution, if our claim is true. This is not part of the question, this is just an add-on, alright? So how do you know if a coordinate is a solution to an inequality? What you do is you plug it into the inequality and see if it satisfies it, alright? So the inequality is y is greater than 2x plus minus 5, so if I plug in 0, 0 for x and y, do I end up with a true statement? So I plug in 0. Is 0, question mark, greater than 2 times 0 minus 5? Now how did I get this inequality here? I took the x value and I plugged it in here. And I took the y value and I plugged it right here. Okay? Now, let's simplify the right side. Is 0 greater than 2 times 0 is 0, 0 minus 5. Is 0 greater than negative 5? Absolutely. So that shows that 0, 0 is in fact a solution to the linear inequality. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback will be greatly appreciated. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips can be found on mathgotserved.com under test prep. Thanks again for watching and have a wonderful day. Goodbye.